It has been shown that 60% of Christmas days in a particular city have had snow. Find the probability distribution of x, where x is the number of snowy Christmases in the last 6 years, and then find the mean and standard deviation of x. Okay, so x is the number of snowy Christmases, and so it could be anywhere from 0 up to the maximum possible in this period of 6. Let's find the mean and standard deviation first, since those are generally the shortest. All right, so the mean, if we can assume we have a binomial distribution, is going to be simply n times p. It's simply a percentage of the n. I mean, there really actually is a long, drawn-out proof for this, but really, you can really look at this intuitively. It's going to be 60% of 6. We'll write it in this order. So we see there are 3.6 and of course the standard deviation, the square root of npq, and q is just 1 minus p. So we have 6 times 0.6, and then the failure rate 0.4, and so we have 0.6 with 6 times 0.24, and we take the square root of this, and we get 1.2. Okay, so the next question then is finding the distribution of x. So remember, the probability distribution means that if we have all possible values of x, which we found there are 7 possible values, and the probability of x having that number of values. So we need to find the probability of 0 all the way up to the probability of 6. Okay, well, let's go to it. You'll find a lot of this gets repetitive after a while once you start 0, 1, 2, 3, 4, 5, 6. Before I continue, though, one more thing I should mention. There are a couple of shortcuts that will have us get through this a little bit quicker. One of them being that, remember the idea of combinations, right? X choose n, and choose x. So we have n factorial over x factorial times n minus x factorial. Let's just throw some numbers in here. We have n equals 6. So we can take 6, choose 2, 6, 5, 4, 4 through 1, 2, and another 4 through 1. Because this is the 4 factorial. This is what's left over from the 6 factorial. These cancel out. 6 times 5 over 2, we get 15. What about 6 choose 4? Well, that's going to be 6 factorial over 4 factorial 2 factorial. All we're doing is reversing the order of these things, and so that's also going to be 15. 6 choose 1 is 6, but 6 choose 5 is also 6. 6 choose 3 is going to be a little more. Then we have 6 factorial 3, 3, 6, 5, 4. Now the 3 through 1 is going to cancel out with this 3 through 1, and all we have is the other 3 through 1, and again 3 times 2 is 6, and so we get 20. So we have 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and 6 choose 6. So we're going to have there's only one way you can make 0 out of 6. There's only one way you can select all 6. There are 6 ways you can select exactly 1, 6 ways you can not select exactly 1. 15 ways in which you can select 2. 15 ways in which you cannot select 2. And so see, there's a pattern here. But this will save us a lot of time, even though, yes, there are a lot of calculations to be done here. So let's start at the beginning. Let's start probability that x equals 0, that there are no white Christmases in that time period. All right, well, let's go ahead and plug these things in. So we have, so n is going to be 6 for all of them. 0 factorial, 6 factorial. And the probability of success, we know, is 0.6. The probability of failure is 0.4. Now I want you to notice something. There's another pattern here that helps us. These two numbers, not the factorials, but these two numbers add to 6. This 0 matches this 0. This 6 matches this 6. And these two have to add to 1. So we're going to see that pattern. So that's an easy way of kind of checking yourself. Make sure that you're on the right track with the substitutions. I'm just going to erase these. And so let's see what we have. We have 6 over 6. That's going to come out to 1. 0.6 to the 0 is going to be 1. And we're just left with 0.4 to the 6. And we have 0.004. And so actually, what we'll do, let's do this. As we move on, we'll fill in the table. Zero, 1, 2, 3, 4. And 4 to the 6 is 0.004, rounded to 3 decimal places. All right, so now we'll just keep going. Find the probability that x equals 1. Well, it's going to be, well, there's only 6 ways. We're just going to go by what we have here. There's only 6 ways to choose 1 out of 6. 0.6 to the 1. That's the success rate. And there's going to be 0.4, and there's going to be 5 failures there. So we have 0.6 times 0.4 to the 5th times 6, and that's going to give us 0.037. Right, let's keep going. Once you see the pattern for one of them, just keep up with that pattern. X equals 2. Well, we found 6 choose 2. We found that's the 15. 0.6 to the 2. 0.4. This time is 4 to the 4. So these numbers are going up by 1. These numbers are going down by 1. 6 squared is 0.36 times 0.4 raised to the 4th power, multiplied by 15, and we get 0.138. Okay, we're almost to the hump. X equals 3. So we saw that there are 20 ways to select 3 out of 6. So once you get the pattern with this, you can do a lot of these very quickly. 0.6 to the 3rd power times 0.3 to the 3rd power, and then multiply all that by 20, and times 0.4. We did look right with that one. Yeah, we got an incorrect answer before. Is that 276? All right. X equal 4. Well, 4, we're back down to the 15. So it's going to be 15 times 0.6 to the 4. 4 successes, 2 non-successes. 6 raised to the 4th power times 0.16 times 15, and we're going to get 0.311. Almost home. X equals 5. If you say that there's 6 ways to choose 1 out of 6, there are also 6 ways to not choose 1 out of 6. So multiply this. So we take that 4 to the 1, and we can take that and multiply times 0.4, and we get 0.187. And finally, the probability of all 6, well, again, there's only one way to select that. 6 successes, 0 failures. And so it's just 0.6 to the 6th power, and that's 0.047. Let's fill those last 2 in. The whole idea here, these probabilities should add to 1. We'll verify that. 004, 037, 138, 276, 311, 187, 047. And indeed, they do add up to 1. Now, sometimes because of rounding, they might add up to 0.999 or 1.001, but in this case, they do happen to add to 1.